All right, so today I can determine if a binomial is a factor by determining if the remainder is zero using the remainder theorem. So let's talk about what it means if something is a factor. So let's say I want to ask you, is 5 a factor of 10? Well, the answer to that is yes, because 5 goes in evenly. If a number goes in evenly, it's a factor. If a number goes in evenly, doesn't that mean that the remainder is 0? So if the remainder is 0, it means that it divides evenly. It means that it's a factor. So yes, 5 is a factor of 10 because it has a remainder of 0. It divides it evenly. So yes, because it has a remainder of 0. Is 6 a factor of 10? Well, does 6 go in evenly to 10? No, there's a remainder. If there's a remainder, it means that it does not divide in evenly. So this would be no, because it does not have a remainder of 0. That's kind of like middle school stuff, and at the high school level, it's going to be the exact same concept. What I need to know is the remainder. If the remainder is 0, then it's a factor. If the remainder is not 0, then it's not a factor. And how do I find the remainder? Well, we just learned in the last lesson, we use remainder theorem. So I can determine if a binomial is a factor by determining if the remainder is 0 using the remainder theorem. Let's take a look at our first example. Is x minus 6 a factor of p of x equals blah, 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 blah? So to determine if x minus 6 is a factor, I need to find the remainder. To find the remainder, I do remainder theorem. So remainder theorem, I'm substituting the opposite of what I'm dividing by into the function. So I'm doing p of 6 equals 6 cubed minus 6 times 6 squared plus 4 times 6 minus 1. So we just did that in the last lesson. We can do it by storing. We can do it without storing, depending on what calculator you have. So I'm going to do it with storing. So I'm going to do 6 store as x. I'll do it both ways. X cubed minus 6x squared plus 4x minus 1. Enter. So p of 6 equals 23. Now, again, if you don't have the graphing calculator, you can just do, with whatever calculator you have, you can just sub in 6. I find it's a little bit faster and easier using the storing function, which is why I'm going to continue to model that. Either way, you get 23. So the remainder is 23. If the remainder is 23, that means that it does not go in evenly. Because if it went in evenly, it would have a remainder of 0. So since it has a remainder, no, it is not a factor because the remainder is not 0. So it's either going to be yes, it's a factor because the remainder is 0, or no, it's not a factor because the remainder is not 0. Because the remainder was not 0, it's not a factor. And again, to find the remainder, we use remainder theorem, which is substituting the opposite of what I'm dividing by into the function. Let's take a look at another example. Is x plus 2 a factor of blah, 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 blah? To determine if something is a factor, I need to find the remainder. To find the remainder, I do remainder theorem, which is substituting the opposite into the function. I'm going to give everyone a minute or so right now to find the remainder on their own. Again, find the remainder on your own. I think that's enough of a head start. I'm doing it with storing. I got 0. So if the remainder is 0, that means that it divides unevenly. If it divides unevenly, then yes, it is a factor. Because the remainder is 0. It's going to always be either yes, it's a factor because the remainder is 0, or no, it's not a factor because the remainder is not 0. If it's 0, it's a factor. If it's anything other than 0, it's not a factor. And again, to find the remainder, I'm using remainder theorem, which is substituting the opposite of what I'm dividing by into the function. Now, number 3 has got a little twist to it, so let's take a look at number 3. I wouldn't be super concerned about number 3, but we're going to talk about it. So, to determine if something's a factor, I need to substitute the opposite of it into the function. What's the opposite of 2x plus 1? Well, technically, the reason that I do the opposite is because I'm always setting the factor equal to 0. So this one is not as simple, and again, this is not going to come up much, but if I'm doing the opposite of it, I have to subtract a 1, and then divide by 2. So what I'm substituting into the function is negative 1/2. It's not going to come up much, but if it's not just x plus or x minus a number, to determine what you're substituting in, you're taking this and you're setting it equal to 0. That's technically what you're always doing, but you don't really have to go through that process if it's just x plus or x minus a number. So we substitute negative 1/2 in. And then I type in 2x squared plus 5x plus 2. I get p of negative 1/2 is 0. So, I feel like I should have done this before. Since the remainder is 0, yes, it is a factor because the remainder is 0. It's either yes, it's a factor because the remainder is 0, or no, it's not a factor because the remainder is not 0. And again, to find the remainder, you are putting the opposite of what you're dividing by into the function. And if it's not just x plus or x minus something, then I'm setting that value equal to 0 to determine what I'm substituting in. So let's take a look at number 4 now. If I want to determine if x minus 5 is a factor, to determine if something's a factor, I need to find the remainder. If the remainder is 0, it's a factor. If it's anything other than 0, it's not. So to find the remainder, I do remainder theorem by substituting the opposite of what I'm dividing by into the function. The most efficient way to do this is to do it with storing. I'm going to do it mine with storing. 5 store as x, 2x cubed minus 4x squared minus 7x minus 10. I get 105. So, since the remainder is 105, is x minus 5 a factor? No, because the remainder is not 0. Boom. That's it. There's one more type of question I want to show you, a multiple choice version of this. It's essentially the same thing, but I just want to go over one of them with you. Oh, I just went right past it. So number 8 here, which binomial is a factor of? Well, we have to go through each choice and determine if each one is a factor. So it's kind of like 4 problems in one. So which binomial is a factor of? Well, if x minus 2 is if I want to determine if x minus 2 is a factor, then I need to substitute 2 into the function. If x plus 2 is a factor, I need to substitute negative 2 into the function. If x minus 4 is a factor, I need to substitute 4 into the function. And if x plus 4 is a factor, I need to substitute negative 4. So, I'm going to start by storing 2 for choice 1. Let me just clear everything else out of here. I'm going to type in x to the 4th minus 4x squared minus 4x plus 8. The remainder is 0. So I pretty much have my answer right there, but I want to go through all 4 choices to be sure. Now check out how easy this is with this calculator. If I want to sub in negative 2 now, I'm going to store negative 2 as x, and then I'm just going to copy and paste my expression. So this becomes very fast if you use the calculator and you use the storing function. For choice 3, I want to substitute 4 in, so I'm going to do 4 store as x, copy and paste the expression, 184. In choice 4, I'm going to substitute negative 4 in, copy and paste, 216. It wants to know which one is a factor. In order for it to be a factor, it has to have a remainder of 0. Therefore, choice 1 is the answer. And the whole rest of this back page is all the same. You're just going to go through each choice and see if it's a factor by finding the remainder. And if you copy and paste and use the storing function, it's going to make your life a lot easier. If you don't have this calculator right now, well, that's rough. You're not going to have that option, but you're still just substituting in and getting your answers. So your classwork/homework is to finish this sheet. And again, to determine if a binomial is a factor, I can determine if a binomial is a factor by determining if the remainder is 0 using the remainder theorem. Either yes, it's a factor because the remainder is 0, or no, it is not a factor because the remainder is not 0. Have a nice night, and if you have any questions, just like always, reach out to me and remind on the Jamboard. I will be there.